Chapter 27. We're going to start with problem number 9. Problem number 9 says a current begins flowing into an initially uncharged capacitor at t equals 0 and decreases to 0 during 0 is less than or equal to t is less than or equal to 2 seconds. Problem number 9. We have a current that flows into an initially uncharged capacitor at t equals 0 and decreases to 0 during this time 0 to 2 seconds with the time dependence given by this equation. So they give us the equation I equals A times t minus 2 quantity squared. And then they tell us A is equal to 0.25 coulombs per second squared. Why they don't just give you that I equals 0.25 times t minus 2, I have no idea. Okay. What is the initial current? What is the current at 1 second? And how much charge is on the capacitor when the current stops at t equals 2 seconds? So, to find the initial current, how can I do that? Bless you. Any guesses? Plug in 0. Plug in 0 for what? T. So when time is 0, plug in 0, and that'll give you your initial current. I at 0 equals 0.25 times 0 minus 2, all of that squared. What's 0 minus 2 squared? 4. Positive or negative? Positive, because negative times negative gives you positive. 0.25 times 4. What's 1/4 times 4? 1. And what are the units? Amps. Okay, we're going southern. Okay, part B. What is the current at time 1 second? What's current at 1 second? Plug in 1 and find out. I of 1 equals 0.25 times 1 minus 2, all of that squared. So 0.25, what's 1 minus 2? Negative 1. Quantity squared, negative 1 times negative 1 gives me 0.25. So hopefully it's 0.25 amps. Yeah. We good on part A and B? Yeah? You don't have to be afraid to talk. You can talk. Just don't have your own conversations until I let you work on your own. Okay. All right, part A, part B, part C. Part C was we have to find the charge on the capacitor when the current stops at t equals 2 seconds. So how much charge is built up on this thing? The purpose of the capacitor was to store charge. So we want to know how much charge we're actually storing. What's the definition of current? Remember this equation? Nah, why would we? I equals dq dt. Amount of charge that flows per unit time. If I want to find the charge, then I have to do some algebra here, and I have to do some algebra and then some physics calculus. So I multiply both sides by dt, and I get I times dt equals dq. So let me just shuffle those over, just back and forth. dq equals I dt. Dairy Queen. My Twitter's exploded lately. I don't know if anybody else's Twitter has exploded.
Yeah.
With Dairy Queen, I keep getting ads for the Valentine's Day Dairy Queen Blizzard.
What is it? I've always wanted to try Blizzard.
It sounds delicious.
What is it?
So I'm gonna hope that my phone rings in the middle of class and it's my girlfriend, and one of you answer it and tell her that she needs to get me a Dairy Queen Blizzard, the strawberry one. I should call her and just have one of you.
You should
call
act
her.
like you butt dialed her and then just be talking
Yeah,
about how
I could
much
do
you
that.
really like Gary.
I should do that. She might be teaching right now, so she might get mad at me.
But you're teaching too, so it's okay.
I am.
Yeah.
So it's
Again,
okay.
it's a butt
Cancels out.
dial.
Yeah.
We'll see how far we get.
You should just have each class just talk to each other.
We should. She teaches a bunch of engineers. You don't want to talk to them.
Oh my
They can
god.
help us.
They're, oh, no, they can't.
And she's gonna be
I should pause this. Foray into Dairy Queen blizzards. How do I find Q then from this? Integrate it. I take the little squiggle of both sides, integrate both sides. And when you're doing an integral, you identify the variable you're integrating over. On the left-hand side, what's the variable of integration? Q. It's whatever is associated with the d. And on the right-hand side, what's the variable of integration? T, because it's with the dt. What does t represent? Time. So we need variables of integration to integrate over. We need times. What times do we go over? 0 to 2. So we want to know how much charge we build up between 0 and 2 seconds. I integrate the left-hand side and I get the total charge, whatever's been built up over that time. And then the right-hand side, I plug in my equation for t, for I, which was 0.25 times t minus 2 squared over that dt. So I plugged in my equation, and now I got to integrate this. What can I do with the integral? Can I pull anything out of it? I can pull out 0.25. That's perfect. .25. I integrate between 0 and 2. T minus 2 squared dt. How do you do that integral? If you didn't know, what could you do? If you have this on the exam and I don't know how to do that integral. Well, yeah, if you programmed your calculator, you can plug it into your calculator. Your calculators will all do these. A lot of it. Most of you probably have to take out your cell phone and Google, how do I do integrals in my calculator? I don't think that would go over. Program it in beforehand, but I do reserve the right to clear your calculators. So how would you do it if I cleared your calculator? So, I gave you some equation sheets. On those equation sheets, there's a general formula. You have this general formula. Oh gosh, what is it? X n plus 1 over n plus 1. So that's how you take the integral of something raised to a power. You take that same thing, raise it to the power plus 1, and divide by plus 1. If there's something with it, then all of that becomes x. So instead of just x to the n plus 1, it would be t minus 2 to the n plus 1. So that then we can apply that general formula. Q equals 0.25 times t minus 2 to the n plus 1. What would that be? 3? Over 3. And I evaluate that between 0 and 2. So Q equals 0.25 times 2 minus 2 quantity cubed divided by 3 minus 0.25 times 0 minus 2 quantity cubed over 3. So I plug in 2 for t and 0 for t. Do the algebra. Plug that into your calculators. And you'll get out your final answer. Or do it in your head if you're feeling fancy. Do it in your head, get the wrong answer, and lose some points. You get 2 over 3 coulombs. So left-hand side is pretty easy. 2 minus 2, what is 2 minus 2? Big fat goose egg, so all of that goes away. And the right-hand side, 0.25 times negative 2 cubed. What's 2 cubed? 8. 8 times 0.25 is 2. The negatives cancel, so we get 2/3 of it. Okay. So that is Doing the algebra out. That was number 9. Okay. Any questions? Bien, bueno, te gusta?
Muchas.
Muchas?
Mucho.
Mucho?
Sí, señor.
Because you said.
Una pregunta? No question?
Does it not?
What?
Go for it. Go for it.
What if you don't have like all? Okay, I was gonna say I calculate the intervals.
Yeah.
So if I don't have like all the steps,
Is incorrect.
interval, then you can answer count that, or do I have to go through this test?
Yeah, I'd count it. Well, so you have to realize that you have to do this,
Yeah,
right?
if I got to there.
You get to there, and then you plug this into your integral, and it spits out the answer. Okay.
Okay, bet.
Right. If you type something in your calculator wrong, I don't give you partial credit.
All right.
Okay.
How many points?
How many points do you think this should be worth on a test?
5. If you're being really nice. It would probably be even like a multiple choice
That's
question.
like a 5-point question. Okay.
So it'd be like 2 on multiple choice.
So, good question. If they give you an equation where the current is changing with the time, then you have to use that dq dt. If the current isn't changing with time, if it's constant, who cares? You don't need to use the dq. If there's a t in your equation, you got to use either an integral or a derivative. Most likely. Kind of a shortcut. Okay, let's do problem number 45. Number 45, we have 3 resistors of 5, 7, and 9 ohms respectively connected in parallel. What is the resistance of the combination? And if the combination is connected to a 12-volt battery, what is the net current? And then what is the current in each resistor? This one does not have a star next to it, which means it should be easy. Let's see. So we can draw this picture. We have these resistors all connected in parallel. R1 equals 5. R2 equals 7. R3 equals 9. Did I scare people away? Okay. These are all connected in parallel. I want to know what is the total resistance of this whole thing. How do I add these? If they're in parallel, do I add normally, or I call it flip-flop?
Flip-flop.
I do flip-flop. So 1 over R total is 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over R total is 1 over 5 plus 1 over 7 plus 1 over 9. The most common mistake that I see is somebody adds up all these and you get 0.45. Is that what our total is? That is 1 over our total. Most common mistake. Half of you in here will do this on your exam. 1 over our total equals 0.45. How do I get our total out of this? Flip it. Flip-flop. So 1 divided by 0.45 will give you what the actual resistance is. So our total will be 2.22 ohms. It's the monk units. You need to meditate. Okay? Any questions on this? No siree bomb. No siree boob. Oh, that's not medieval. 2.22 ohms. Okay. Now what they ask us to find If this combination is connected to a 12-volt battery, what is the current? So I know V total is 12 volts. How do I find I total?
Change in V over R.
I equals V over R. So 12 over 2.22. 5.4 amps. This is 45?
Oh, okay. Oh, my bad.
Yeah? 12 volt battery.
Nice,
I thought the volt was
Okay. You tried. Thank you.
A for effort, Eric. Honestly, that's all that matters.
Like to his face.
It sounds
does,
sarcastic.
right?
It sounds
Sounds
very
like-
sarcastic.
So genuine.
No, it's not.
I think it's genuine.
I don't know if it is.
For Creedy's a math major. Usually math majors are nice.
usually.
Not always. Okay, part C. What is the current in each resistor? How do I find the current in each one of these?
You do an
I individually. So if I want I1 is V1 over R1. What's V1? Still 12 volts. Why?
That volt is going through each of them because it's a series.
If you're connected in parallel,
Or parallel.
then the voltage stays the same. Because I have 12 volts here, I go back to my original circuit, which is 3. They're all connected in parallel. Each one of those gets all 12 volts. So V1 is 12, V2 is 12, V3 is 12. If I know all the voltages, I know all the resistances, I can get all those currents. So it's 12 over 5 for I1. I2 would be 12 over R2, which is 7. I3 would be 12 over R3, which is 9. So then just do those divisions. 12 over 5 is 2.4. 12 over 7 is 1.7. And 12 over 9 is 1.3. All amps. And what should these all add up to? 5.4. So the nice thing about circuits is you can check your answers. Everything should be consistent. If I have 3 resistors, the currents through each 3 of those resistors should add up to the total current if they're connected in parallel. How many points is this worth? Maybe 5. Yeah. This is easy. Right? This is plug and chug. That doesn't take a long time. What takes a long time is the next one. So let's do number 61. 61 gives us a picture that looks like this. R1 equals 2, R2 equals 4, and R3 equals 6. If I give you a problem like this on the exam, I'm not going to bother reading what the book says. What I would give you is, okay, find the voltage, find the currents and resistances of every single one of these. And I might give you something a little extra. I think the book gives us something a little extra. It does tell us eventually that there is a voltage total of 8 volts. So you'd have a problem like this and be told, find voltage, current, and resistance of each one of these. Everybody should get at least a third of that right. What should you know? Resistance. You should know the resistance is, right? R1 is 2, R2 is 4, R3 is 6. Done. Now I got to find the currents and I got to find the voltages. Now to do that, I need to simplify the circuit. I need to break it into just one resistor, and then I need to work backwards from there. So let's show you how we do that. So I have a R1 is in series with R2 and R3. Can I just add them all together then?
No,
No, why not?
because the other two are in parallel.
Because these two are in parallel. So before I can add them in series with R1, I need to combine these together into one resistor. So I do that. And I like to redraw my pictures. You don't have to do this. This just helps me because I'm a moron. I can't keep track of things in my head. R1, and I'm going to call that R23. Combination of resistor 2 and resistor 3. How do I find R23? So 1 over R23 is 1 over R2 plus 1 over R3. So that's 1 over 4 plus 1 over 6. So 1 over R23 gives me, actually didn't write it down. Somebody add those up for me. What do we got?
1, 6, 7, or just 4.2.
You got what?
4.2.
Say it louder.
4.2.
4.2?
Oh,
That
sorry.
shouldn't have been.
Okay.
0.42?
Yeah, I wrote it wrong.
Okay. 4.2, I would have been worried. 0.42. Is that the resistance? No, what do I have to do? Flip that number upside down. R23. What is R23 then? Logan? 2.4. What are the units on that? Ohms. Okay. Don't forget to flip this number. It's very weird. I asked, what do you do? And multiple people all said add it. We all had the wrong, right? The same wrong answer. Huh? R23 equals 2.4. I almost got hit by a car today. That person was being very rude, so. That's fine. Sure. Sure. Okay, how do I add R1 and R23? Just straight up add them? Why can't I just straight up add them? Because they're in series. Add them. R123. R123 is R1 plus R23. R123, R1 is 2. R23 is 2.4. So what's R total? 4.4 ohms. So now I have a ton of information. I know the total resistance, 4.4 ohms. Ohms.
Yeah, it was
Okay. Now I can find all the things I can find about the single resistor and then start working backwards with that information. Do I know what V123 is? The total voltage going through this resistor. I do. What is it? I know V123 is the total voltage. V123 is equal to 8. So can I find I? By doing V over R. I do that division. What do I get for I123? I get 1.8 amps. Now I can take this and I can go backwards one step. Going from one resistor to two resistors. How are these resistors connected? They're in series. What stays the same in series? The current stays the same. So what current is going through each of these is the same current as you had in the one resistor. Whenever you go back one step, that number stays the same. If these were in parallel, what would stay the same? Voltage. So I go backwards, and I know that I1 is I123. I1 is 1.8 amps. I23 is 1.8 amps. R1 is still 2. What's V1? How do I find V1?
Yeah.
I times R. So we have 1.8 times 2. We get 3.6 volts. I can do the same thing. R23 was 2.4. And I can find V23. I have two different ways that I could find V23. Multiply those two numbers together, you got 4.4 volts. How else could I get 4.4 volts?
Subtracting.
Subtracting. 8 total volts going through both of these. The first one eats up 3.6. 8 minus 3.6 gives you 4.4. So you can do I times R, or you can use subtracting the voltages. Great. Now I go backwards one more step. What's changing between here and here? My R23 is now 2 resistors. How are those resistors connected? Parallel. In parallel, what stays the same?
Voltage.
Voltage. So the voltage from the previous step stays the same in this step. What voltage was going through R23? 4.4 volts. So V2 and V3 are each 4.4 volts.
Wait, what did you say you can multiply instead of subtract? To find the difference.
I times R. I23 times R23 give you V2. Yep. So V2 is 4.4. R2 is 4. So what's I2? What's 4.4 divided by 4? 1.1 amps. How many amps do I have total? 1.8. If I take 1.8 minus 1.1, that will give me what I3 is. .7 amps. How else could I get that? What's V3? 4.4 volts. What's R3? 6. 4.4 divided by 6, well, you'll get 0.7. There are multiple different ways to do this. You don't have to write out all of this if it doesn't work for you. If you can work quicker by not doing this, you can do that. The approach I'm showing you will work every single time. Do it step by step by step. You'll always get the right answer. It takes a little bit longer. But if you're confused, lost, you can just write this out, follow these steps, it falls out. These are puzzles. This is the most fun that physics gets. Until the end of the semester when we actually do fun physics, where you don't have to do math.
Fun physics.
No. Any questions on this one? No? Okay, somebody did ask about 62, but 62 is basically the exact same as 24. I don't know why it's starred. It's the exact same. So you solve it the exact same way. It's 3 resistors connected in parallel. No other questions on that? No?
You said 62 is the same as which one?
24.
Which one is it?
The one that I just did in class.
61.
Or sorry, no, 45.
Okay, all right.
I don't know numbers.
Okay.
I do math with letters.